In this example, we're going to look at how to factor a difference of two perfect cubes. Difference meaning we have subtraction of two things that are cubed. So this will follow the structure that it will break into a binomial times a trinomial. And the way we're going to fill in the first spot of this, both the binomial and the trinomial, will be using the first term over here. This a cubed, one factor of a is going to go here in the first spot of this binomial. The other two factors of a times a is a squared, will be used to fill in the first term in the trinomial factor for that. I'm going to do the same thing with the last term here to fill in the last term of this binomial and the last term of this trinomial. One factor of b cubed here, that would just be b, and the other factors, b times b, would make b squared over here. Notice again I have a trinomial I've been speaking of over here. A trinomial has three terms and currently this only has two terms. I still need to fill in this middle term. This middle term is found by just taking the product of these two things. A times b right here is just a b. Once again, I didn't fill in any signs yet. The signs here follow a pattern. We have an acronym to help remember that. SOAP stands for same, opposite, always positive. Sometimes that helps students. So this first sign will be the same as the sign in the original problem, which will be minus. The next sign here is always going to be the opposite of that, which in this case is plus, and the last one will always be positive, so always plus at the end with that. So here we've kind of factored a generic form of this, the a cubed minus b cubed. Let's look at an example here. I throw maybe some numbers in the problem. Maybe I look at x cubed minus 64. That is a difference of two perfect cubes. Again, if you know your perfect cubes, this will be much easier to recognize. This 64 is actually 4 cubed. 4 times 4 is 16, times another 4 is 64. That being said, I'm going to rewrite this as x to the third minus 4 to the third, so we can actually see the pieces that are being cubed like that. I didn't really need the parentheses there, but for some of the more complicated problems where there's multiple pieces with a number and a variable, I've just kind of become in the habit of doing that when I show that step for that. So again, the structure will become a binomial times a trinomial. So 2 terms, 3 terms. Always remember that structure. That goes a long way in helping out. And one factor of x here. The other two factors of x times x is x squared there. One factor of 4 here. The other two factors of 4 times 4 is 16 over there. How do you figure out the middle term? It's just the product of these two things. X times 4 is 4x. I didn't fill in any signs. Same as the original. Opposite of that, always positive. And I've factored this difference of cubes.